Good morning, dear friends. In today's lecture, we will discuss on conic section. In previous lecture, we talk about rotation of axis, how to translate the axis. Here, we will discuss on conic section, how to find center of the conic also. So there are different types of conic like parabola, ellipse, hyperbola, like that. So with the help of given equation, without doing some geometrical work, we can find the nature of the equation, means is it parabola or ellipse or not. So let us start. Friends, we already started unit 1. We completed topic change of axis, translation and rotation. Now in today's lecture, we'll discuss about conic section. So these are some examples of conic section. If you cut this 3D surface by some plane like this, these are diagrams, especially say 1.4, then we get the hyperbola. Then if you cut, especially see the diagram figure 1.6, if you cut the plane which is perpendicular to the axis of the cone, and we get the circle. If the plane is parallel to the generator of the cone, then section is parabola. See the diagram figure 1.7, and see the figure 1.8. If the plane is oblique, means that is not parallel to or perpendicular to some like axis of the cone, then oblique to the axis, then cut the cone in one side, and that is we get the ellipse. See the diagram 1.8. Now see this diagram figure 1.9. If the plane is parallel to the axis of the cone, and if you cut, then section is parabola. That is such type of cut. Now conic, some definition we should go. Conic is defined as a locus of a point which moves in a plane such that the ratio of its distance from fixed point in the plane and its perpendicular distance from a fixed line is constant. Note that the locus of a point is collection of all points which are going in a particular path, or see, which moves in a plane such that the ratio of its distance from fixed point in the plane and it is perpendicular distance from a fixed straight line is constant. This definition you already learned in 12th standard also, so we are not going into detail. So just take the brief introduction. Focus. The fixed point in the plane is called focus of the conic, and it is denoted by S. Directrix. The fixed straight line is called directrix of the conic and is denoted by D. What is its eccentricity? The constant ratio is called eccentricity of the conic, is denoted by E, and there are three types of conic, say E equal to 1, then conic is parabola. If E is strictly less than 1, then conic is ellipse, and if it is greater than 1, then conic is hyperbola. Now equation of conic. Let S having coordinates say x1, y1 be the locus and D is directrix. That is a straight line. That is straight line is denoted by ax plus by plus c equal to 0. Or in 12th standard you also learn another form is y equal to mx plus c. Be the equation of the directrix. Let point P having coordinates say x dash y dash moves in the plane. So PM is perpendicular to D. For the conic, see this diagram. PS, length PS divided by PM. If that ratio is constant, and that is always constant because P is point fixed, this line is fixed, S is fixed. So that ratio is called E. And as per we already discussed that E is equal to 1, then it is parabola. E less than 1 means it is ellipse. It is greater than 1, then it is hyperbola. And after using the distance formula, then by using some simple calculation, then we get the second degree equation in xy. So the conic is represented by second degree equation in xy, and by considering the discriminant of the second degree equation and the nature of eccentricity, we may conclude that general equation of the second degree is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. And note that this is very important. So this is general equation of second degree and represent the parabola if h square minus ab equal to 0, and if it is if h square minus ab is strictly less than 0, and it is hyperbola if h square minus ab is strictly greater than 0. What is h? H is a coefficient of xy divided by 2. What is a? Coefficient of x square. What is b? Coefficient of y square. So while solving problem on this, you will have given some general equation and you have to show that it is hyperbola, or check whether it is ellipse or parabola, or ellipse or hyperbola, or parabola or hyperbola, such that. So how we can decide whether the given equation represents the equation of parabola or hyperbola or ellipse or not? So these are the conditions, these are the test. Means by checking if h square minus ab having value is 0, then it is parabola. If it is negative, then it is ellipse. If it is positive, then it is hyperbola. Then last, fourth is important. That equation represents circle if a equal to b and h equal to 0, provided abc plus 2fgh minus af square minus bg square minus ch square not equal to 0 for all four cases. Means observe that coefficient of x square and coefficient of y square should be same, equal, and coefficient of xy should be 0, means xy terms should be absent, then it represents circle. Now we have shown every conic represent the second degree equation, and the converse of this is also true. If we now prove that every general equation of the second degree in xy represent a conic. Dear friend, that we already know the general equation of circle, like ax square plus or x square plus y square plus 2 hx plus 2 fy, sorry, we use your familiar notation. General equation of say sphere is x square plus y square plus z square plus 2ux plus 2uy plus 2wz plus d equal to 0. So from this we can't calculate directly that what is center and what is radius, but from the center radius form we can easily calculate the equation of sphere. Same thing about circle also. Means we have given the general equation of circle, then it is not easy to calculate the center and radius of this general equation of circle as compared to this one, as compared to center radius form. Here we can easily calculate the radius and center is origin, because here center is origin. In the same line, suppose we have given parabola or say ellipse, so we can't calculate easily center of this ellipse, but if you are given that ellipse in a standard form, say such type of ellipse is given, then we can easily calculate the center, obviously that is origin, and semi-major and semi-minor axis also. Here it is difficult to calculate the semi-major and semi-minor axis. So I think you understand what I am talking about. So we have to use the shifting of origin to prove that every general equation of the second degree in xy represent conic. So I just use small brief idea of this. So this is one equation representing the general equation in second degree, and we know that represent pair of lines if satisfy this condition, is delta equal to 0. Suppose delta not equal to 0, then it may be conic, means either parabola, ellipse, hyperbola, circle, like that. Circle is a particular case of ellipse. So what we have to do, we have to rotate the axis and angle by angle theta, and doing some calculation we have to equate coefficient of xy is like this, and in short we get this equation: ax square plus by square plus 2gx dash plus 2fy dash plus c equal to 0. Now we have to make the cases, like if a equal to b, then it represents circle. If it satisfies this condition, then it represents ellipse. We no need to go in detail. Let us come or focus on center of the conic. What is center of the conic? Again, observe that this is x-axis, this is ellipse, then this is origin is center of the ellipse. For this ellipse, this is the center. For this ellipse, this is the center. Similarly, we can talk about parabola, circle, hyperbola. For this hyperbola, this is a center. So, how we have to calculate the center? If we are given the equation in xy, second degree equation, then how we can calculate it algebraically instead of geometrically? So for that we have to use this discussion. Proof may be asked that find the formula or show that center of the conic section is given by like this way. So let x1 y1 be the center of the conic of this equation 1. Shift the origin to x1 y. Now we discuss center of the conic. So whatever general equation we have given in a form of say ax square plus 2h xy plus by square plus 2gx plus 2fy plus c equal to 0, and suppose x1 y1 is a center for this one, then first job is we have to shift origin to the x1 y1. So then by the discussion of previous lecture, means we have to replace x1 by capital X plus x1, y1 by capital Y plus y1. So we get the new equation, and note that that equation is represented by 2. After simplifying we get a capital X square plus 2h capital XY plus b capital Y square, like this. Since the center of the conic is now at the origin, this is very important. We have to shift the center of the conic to the origin by replacing x by x1 plus x, by replacing y by capital Y plus y1, where x1 y1 is a center of the conic. Now this equation 2, its center is now origin. The coefficient of first degree term in x and y in the equation 2 must be 0. As per our discussion, that conic has such type of, it has xy term is vanishes. So x coefficient of x and y, its term must be 0. So what is coefficient of x? This is the coefficient of x, is means this part will be 0. Actually 2 into this coefficient, but divided by 2 we get this is also 0 obviously. And second thing is here also coefficient of y means this, that is 0. So in short, this equation denoted by V3. Solving these three for x1 and y1 by using Cramer's rule, So we get value of x1 is h f minus bg divided by ab minus a square, means value of x is hf minus bg upon ab minus h square. Value of y1 is gh minus af upon ab minus h square. So this should represent the center of the conic. This is a very important formula. Now we discuss. Now note that this is the center of the conic, and observe that denominator ab minus a square for both x1 and y1 is same, and if it is 0 and if hf minus bg not equal to 0, then infinity will be their center, and the conic is parabola. This remark is very important, that for a parabola center is infinity, and if ab minus a square equal to 0 and hf minus bg also equal to 0, then center is indeterminate and conic reduced to the pair of parallel lines. These remarks are useful. Now we take problem on this. Reduce the equation seven x square plus 8xy plus y square plus 52x minus 22y plus 76 equal to 0 to its standard form and obtain the center. We will discuss more on this problem also, but before that we should first find the center of this conic. Discuss in detail later. Suppose geometrically what happens? We should know to find the center we have formula. So just focus on this problem. Obtain the center of this, and we know the, or we can say this is as a second problem. Find center of conic, and we have given 7x square plus 8xy plus y square 52x minus 22y plus 76 equal to 0, and second is also find nature of conic. So first we focus on to find the nature of conic. Here solution. Here compare this equation 1 compare with ax square plus 2xxy plus by square plus 2gx plus 2fy plus c equal to 0. So we get a is equal to 7. Here coefficient of x square is a, that's a equal to 7. B equal to coefficient of y square, that is b, that is equal to 1. H equal to coefficient of xy, coefficient of xy divided by 2, we get the h. So 2h is equal to 8. Note that 2h is equal to 8 implies h is equal to 4. Third is, or from up to this data, actually we have to compare all these, but first we focus on this one. We know the remark a square minus ab. If it is 0, then parabola. If it is negative, means less than 0, ellipse. If greater than 0, then hyperbola. So 4 square minus a is 7, b is 1. So 16 minus 7, that is 9, and that is positive. So this implies hyperbola. Conic equation 1 represent hyperbola because h square minus ab, that is greater than 0. If it is less than 0, then ellipse. If equal to 0, then parabola. Now we try to solve center of the conic. Means to find the center of hyperbola. Now to find center of 2 is conic hyperbola, you can say. So what is formula? It contain, formula contain h, b, g, a, b, like this. So we already got here a equal to 7, b equal to 1, h is equal to 4. Also, what is g? G is minus 26, because observe here, to find the g, that is coefficient of x divided by 2. Coefficient of x is 52 divided by 2. Here minus is there. Sorry for I have to make the correction. So coefficient of x is minus 26. That is value of g. Actually minus 52 divided by 2. G is equal to minus 26. Y is equal to minus 11 and C is equal to plus 76. Just we are comparing. So F is equal to minus 11, C is equal to 76, and we know the formula. Center of conic is given by like this. HF minus BG EAB minus A square GH minus EAF AB minus H square. I will tell you on in some lecture how to remember such type of formula by using memory technique. So just substitute these. So we get, because we know the value of H, G, A, B, C, all these. So substitute there and we should not take interest in calculation, avoid calculation part and directly go towards like this. So that is nothing but the 2, 3. So center of hyperbola is 2, 3. So in this way we are finding center of the conic.